Okay guys, let's begin this walkthrough. So, number 1, part A. Write down the inequality shown on the number line. So the best way to do this is always write x first, yeah, because that's what we're dealing with. And we ask ourselves, alright, so where is the ball? The ball is at -3, and it's not shaded in, so we don't include it. And we can see that the line covers all of these numbers bigger than -3. So that means the values that x could take would be bigger than -3. And that's our answer. Now, part B, solve this inequality. Alright, so when you solve an inequality, just treat this sign over here like an equal sign, yeah? So just imagine it was 4y minus 13 equals y plus 8, okay? But instead of the equal sign, you can just keep it as the inequality. Now, to solve this one, we should move all the y terms to the left and the number terms, i.e. the non-y terms, to the right. So to move y across, it's a positive y. Move across the equal sign, you subtract y. So 4y take away y is 3y. And then moving minus 13 across, you go add 13. So 8 plus 13 is 21. And therefore, to solve this equation here, you just got to isolate the y from the 3. So you got to divide 3 across. And doing so, you got y less than equal. 21 divided by 3 is 7. And that's it. Y is less than equal than 7. Alright, number 2. Show that this equation here equals the right hand side. So what we have to do is simply resolve this one without using a calculator and somehow make it look like this result here. So to do this, the first thing we need to know about adding or subtracting fractions is that we must always have common denominators, and that is these values here. They have to be the same. Now to make it the same, and before we even get there, we should first change mixed numbers which look like this into improper fractions. So single fractions. So let's do that right now. So for 5 2/3, the easy way to do it is to simply multiply the whole number with the denominator, 5 times 3, and add it to the top. So 5 times 3 is 15, add 2 is 17, and 17 over 3, minus, same thing applies, 2 times 4 is 8, plus 3 is 11, and that's over 4. So since we got that done, all we need to do now is make common denominators. So we ask ourselves, alright, how can we make both these digits the same? Well, the trick is to multiply them by what they don't have. So because this is over 3, you should multiply up and down by 4. Because it's over 4, we should multiply up and down by 3. So we just pick the opposite numbers. And doing so, if you times up and down by 4, we're going to know for sure they're both going to be over 12. So this means you're going to have 17 times 4, and that's going to give us 68. And 3 times 4 is 12. And just to be clear, they're both over 12, yeah? And 11 times 3 is 33. And now we just tidy up. So we've got 68, take away 33. That's going to give us 35 over 12. And now the last step is to change this into a mixed number. Well, what you could do, you can just smash in your calculator right now. You could even do this in your calculator. This will give us this result. And then you can use your Casio calculator to shift it to a mixed number. But if you're not sure, we can just say, all right, 12 into 35 goes exactly 2 times and you get a remainder of 11. So you could just copy it straight out. And that's it, guys. This question is done. Alright, for this question I shrunk it a bit so I can fit everything in one page. But let's have a look. It says that we need to complete the table of values for this equation right here. And here's our table. Okay, so this is so easy. So all we have to do really is just replace your x values with whatever value it is. Just put all in the calculator, this equation, and then you should get a y value in return. So for example, let's plug in -1, yeah? So we have y equals 1 plus 5. Now instead of x, we're going to replace it with -1. And I always recommend you wrap it around, replace layers and wrap it around in a nice bracket. And then minus -1 squared. And then putting this in the calculator, you should get a result of -5. And that should go here. And then you do the same for each value. So for 1, you replace these terms here with 1. So you get 1 plus 5 times 1 minus 1 squared. And here you should get just a result of 5. And doing again for 4 and 6, you should get 5 and -5. And that's it. This part will be done. Now as for part B, it says on the grid, draw the graph of what we just found for the values of x between -1 and 6. In other words, plot all of these coordinates in, yeah? Oops, why did I rub it out? 5, 5, 5, -5. So let's plug them in, yeah? So we got first thing, -1 and -5. That basically tells us that at -1 on the x, we're going down to -5 on the y, which is here. And the next one, 0, 1, we're at 0 on the end. 1 here, go up to 5, and so forth. 2, 7, 2 up to 7. I'm going to speed this up a bit now. Now, at this stage, we're going to connect it. So here you go do this freehand, yeah? So do not use a ruler because it's going to be a curve, yeah? So to do this, it's kind of hard. You're going to curve it like this. Okay, not kind of like that. And then, but you got to make sure you cut through every single corner. So, hold on. So like that. But anyway, have a go, yeah? It should look a lot better than that. All right, number 4. So ABC and DEF are similar triangles. So similar means they are pretty much the same triangles, but proportionally bigger, yeah? So whatever one length is because it's been scaled upwards, yeah? And same thing applies to everything else. Now, part A, work out the length of DE. So DE would be this side, which we're going to call X. Now, the easy way to do this is to basically look at two similar lengths. In other words, looking at 16 and 40 and asking yourself, how many times bigger is 40 to 16? Well, a quick way to do it is to just divide them, yeah? So in your calculation, write 40 by 16. And doing this, you should get a scale factor of 2.5. So this means that every single length here has been increased or multiplied by 2.5. Now to work out X, then we do the same thing. So we got 12. Since we know our scale factor is 2.5, we're going to just multiply onto 12. So 12 times 2.5 should give us 30. So 30 centimeters. Now for the last bit, it says that the area of triangle DEF is 525 centimeters squared. Okay. Find area of triangle DF in meters squared. Okay, that's easy. So there's nothing, you don't need to do no similar triangles or nothing. Cool. All right, so all you have to know, to go from centimeters squared to meters squared, well, before that, to go from centimeters to meters, we need to know that we need to multiply this or divide this by 100. Okay, so there's a scale factor 100. This means going from the squared version, you got divided by 100 squared. If it was cubed, you would divide it by 100 cubed. So in other words, in our calculator, we're going to write 525 centimeters squared divided by 100 squared. And when you do that, you should get an answer of 0.0525 and meter squared. That's it. Not much to it, guys, yeah? And that's number 4 done. All right, my favorite question. Factorize x squared minus 5x minus 36. All right, not bad, not bad. So to do something like this one, it's just straight up easy, yeah? All we do is first things first to realize that this needs to be in this following form, which is a double bracket form. That's what we want it to be. And to do so, we just look at the last digit, 36, and we write down all the pairs of numbers that multiply to make 36. Well, the first one I can think of would be 6 times 6. Another pair would be 1 and 36. Now, is there any other pairs? Yeah, there's also 4 times 9, so 4 and 9. And I think that's about it for now. Yep, that's about it. So now the next step is to basically pick one of these pair numbers that have a sum or difference of minus 5, yeah? Don't worry about the minus 36. Think of something that has a sum or difference of minus 5. And the one I can think of right now would be the third pair. And the only way to get a difference of 5 if you did minus 9 and plus 4. And that's it, guys. You just put it in the brackets. So you're going to get x minus 9, x plus 4. And just to be sure this is right, you can also see that minus 9 times plus 4 gives us minus 36. And minus 9 add 4 gives us minus 5. And that's it, guys. That's 5 done. All right, so after the easy one, now we got kind of a longer looking question. So let's check out number 6. It says here that there are some ice lollies in the freezer. The flavor of each ice lolly is banana or strawberry or mint or chocolate. Man, don't these guys ever use commas? Julius takes at random an ice lolly from the freezer. The table below shows the probabilities that the flavor of the ice lolly that Julius takes is banana or strawberry or chocolate. And don't forget, there's also mint. You kind of forgot what to say. Work out the probability that the flavor of the ice lolly that Julius takes is either strawberry or mint. When they say either strawberry or mint, this means you got to add up the probability of strawberry and whatever mint is. Now the question is, what is mint? Well, one thing we always need to know about probabilities is that the sum of all the probabilities must always add up to 1. And that's if you add them up, yeah? So basically, let's just call mint m for sake of it, yeah? This means that all these values, you just add them up. So 35 plus 32 plus 12. and then you put that in decimal, so there's 0 point all of them, 1 minus all of that, and min should be 0.21 left. So just double checking that, yeah? 0.35 plus 0.32 plus 0.12, that should give you something. 1 is 0.21. That's min. And therefore the question says, work out the probability that the isolate could be either strawberry or mint. And since strawberry is 32, the answer would be 0.21 plus 0.32 should give us 0.53. And that's it. Alright, number 7. So a football team played 55 games. Each game has one drawn or lost. Okay, so you've got 3 different things going on. So the number of games won, 2, so this is a ratio. 2, the number of games drawn. 2, the number of games lost is 632. So this means that for every 6 games won, you're expected to draw 3 times and lose 2 games. So that's for this particular team. Work out how many more games the team won than the team lost. Alright, cool. So this is a very standard ratio question, yeah? So what they're trying to say here, with this ratio parts, we must always add up all the ratio parts. So adding up 6, 3, and 2, this should give us 11 parts. Now this tells us that 11 parts must equal the sum of the games. So we have 55 games, and that should equal 11 parts. Now all you want to do is just work out how many 1 part is. Oh. So to get 1 part, just divide what? 11 across. So you get to get 1 part. 55 by 11 is 5 games. This means to get these parts, 6, 3, and 2, just times it by what you need. So let's see, to get 6 games, so 6 parts, so 5 times 6 is 30, 3 times 5 is 15, 2 times 5 is 10. That's it. And just to be sure this is alright, if you add all this up, it should equal the number of games now. 30 plus 15 is 45, plus 10 is 55 parts, so 55 games. Now the question says, work out how many more games the team won than team lost. And remember, 1 is here, is this part, and lost is here. So they won 30 games, lost 10. 30 take away 10 is 20 games difference, yeah? That's it. This is the end of your question. And finally, number 8. So we're given 2 different values for a and b, which are in terms of prime factors, okay? Part A tells us to find the highest common factor of a and b. Highest common factor, which is a really nice trick, just look at the word factor. So if you look at 3 squared, 3 power 4, and so on, all they want you to have is simply what can they both have at least. So we know that this first term, 3 squared, there's 2 sets of 3s, but there's 4 sets of 3s here. We know that both a and b both have at least 2 pairs here, so 3 squared. So we're just trying to find what they both have at least. The next term, 5 power 4 and 5 to the power of 3, they both have at least 3 each. This has an extra one, so just 5 to the power of 3. Next term, they both have at least a single 7, so it's 7. And finally 11, well, a doesn't have 11, so there is no common factor. So that's it. This would be your end result. And you don't have to expand it, you can leave it like that. It doesn't tell you give it in ordinary numbers or leave it in prime factors, so this is cool. Now part B. Find the lowest common multiple of a and b. And again, the keyword here is multiple. And what I would do, I would rewrite this word as maximize. Yeah, so this is a keyword. When you think LCM, think M for maximize, not multiple. And all that tells us is that we do the same kind of thing, but instead of looking at the common factor, we look at the highest power of both. So this is 3 to the power 2, this is 3 to the power 4. The highest power is 4, so it's 3 to the power 4. Next one, 5 to the power 4 and 5 to the power 3. The highest power of both of them is 4. So again, we're just maximizing the powers, yeah? Next one, 7 and 7, well, the highest power of both is 1, so it's just 7. And again, this one has an 11, this doesn't have 11. So the maximum between 11 and not having 11 is 11. And that's it, guys. That's pretty much how you do both these questions. So we need to write 840,000 in standard form. So to write something in standard form, the trick is to always just highlight the very first non-zero number. In this case, it's 8. So in this case, it'd be 8.4 times 10 to the power. And we just count how many numbers after the 8. So we got, let's see, 1, 2, 3, 4, 5. So it's just going to be 8.4 times 10 to the power of 5. So just remember that for every standard form value, the first digit should always be less than 10. Yeah, so it'll be 8 8.4. So it's not going to be 84, but 8.4. Now, let's look at part B. So work out this entire thing and give it your answer in standard form. Now, this is easy. All you have to do is just smash all of this into your calculator. So make sure you copy everything, including the brackets. And when you do so, you should get 750 million. So this size number. And then once again, put that in standard form. So just like the first method, just highlight the first digit, which is a 7. And then write point and then copy any non-zero number like 5. And then write times 10 to the power. And you just count how many digits are after the 7. Well, you got 2. 3 more, which is 5, another 3 more, which is 8. So 7.5 times 10 to the power of 8. Okay, number 10. So Henry or Henri buys a yacht for 150,000 euros. The yacht depreciates in value by 18% each year. So highlight this and highlight the original amount. Work out the value of the yacht at the end of 3 years. Give your answer correct to the nearest euro. Okay, this one's fine. So for every single percentage or compound interest or depreciation question, you must always write this. We need to know what the original value is, and then we have 1 plus or minus a rate, which will give us a new value. And because you've got years involved, we always put the power over here. In this case, it will be power of 3. Always on top of this bracket. Now, what is everything? Well, the OV is the original value of the item, and the NV is the new value, and the R is the rate. So in this case, our original value was the price of the yacht, which is 150,000. And now we know for sure that the yacht depreciates. In other words, it decreases by 18%. So the rate would be 1 minus 18%. Because it decreases, you use the minus sign. If it increased or compounded, then it will be a plus. And we know all of this to the power of 3. And that's it. And now all you do is just literally put this in your calculator. By the way, guys, yeah, if you don't know how to put the 18%, just rewrite this digit as 0.18. So it'll be 1 minus 0.18, all to the power of 3, and you multiply by 150k. And when you do that, you should get your answer to the nearest euro of 82,705 euros. And that's it, guys, yeah, all good. So line L is drawn in the grid. So here is a nice thick line L. And they want us to find an equation for this line. So every time we have a straight line equation, we always think y equals mx plus c. So something like this, where m is the gradient and c is the y-intercept. Now, looking at this equation head on and looking at the graph, we need to figure out what m and c could be. And once you find that, you're done. Well, since we got c is the y-intercept, we know that it intercepts the y-axis at -1, which is right here. So that's -1 done. That's the value c. And for the gradient, well, you just pick any two coordinates and use the gradient formula. So for example, I'm going to pick, let's say, I don't know, this coordinate here and this coordinate here. So this coordinate here is -2 up +3, and this one here is -1 +1. Okay. Now the gradient formula is always the change in y over the change in x coordinates. Well, the change in y is the difference between the y's. So the difference between the y's would be the difference between 3 and 1, which has a difference of 2. And the change in x is the difference between -2 and -1. Well, it only has a difference of 1, so it'd be 2 over 1. And now one more thing to note. We need to know whether the gradient line is going upwards or downwards. So I should write plus minus. So because the slope is going downwards, it's going to be a negative sign. If the line was going this way, it would be a positive gradient. So downwards, negative gradient. So our gradient is going to be -2 over 1, which is -2. So therefore, replacing all the values here, we're going to have y equals -2x. Instead of plus c, we're going to have -1. And that's it. All right, number 12. So here they want us to calculate the length of AB, which is this diagonal line here. Okay, show you're working clearly and give your answers correct to 3 significant figures. All right, so straight to the point, no fancy words. I love it. Now, one thing we have to always notice in these questions, yeah? You got 2 triangles and they're both right angled. And because they're both right angled, this means that we could use either Pythagoras Theorem or Sohcahtoa. In other words, trigonometry, yeah? So Sohcahtoa is probably the most likely thing we're going to use, only because you got angles involved as well. And you might have to use Pythagoras Theorem, so we'll see about that. Now, let's have a look. Now, the only way to work out this length AB, this x1, if we had a length here or a length here. Now, looking on the right side of the triangle, we can actually work out a length over here, only because we got a value of 3.1, we got 32 degrees, and we can work out this unknown length, and we can call that length y. So just pulling out this right angle triangle here, so we got y, 3.1, and 32 degrees. So, and now look at this triangle, we have to ask ourselves, what does y in 3.1 represent? Well, opposite 32, the y is the opposite, and the long diagonal side is the hypotenuse, always opposite the angle. So looking at this, we got O and H. So, and looking at Sohcahtoa, we ask ourselves, what consists of O and H? And that would be so, because that's O and H. And so represents the sine, so S of sine, of the angle, which is 32, and it must equal opposite, which is y, over the hypotenuse, which is 3.1. Now, all you want to do, guys, is just rearrange this to make y its subject. So multiplying 3.1 across, you're going to have y equals sine 32, all of that times 3.1. In your calculator, you should get a y value of 1.64, something. Now, since we know the value of y over here, let's rewrite the left triangle, yeah? So it's just basically simple Sohcahtoa, yeah? That's all you need to do. So update your values, 1.64, we got 42 degrees, we want to find x. Once again, using Sohcahtoa, we ask ourselves, what does the 1.64 in x represent? Well, in this case, looking at this, if the 42 degrees here, this length is the opposite, therefore next to it is the adjacent, and this long diagonal is always the hypotenuse. So what part of Sohcahtoa has A and H? Well, looking at it carefully, it's going to be ka, and C is the cos. So it's going to be the cos of the angle, which is 42, equals adjacent, which is 1.64, over the hypotenuse of x. And just like the other one, we need to make x subject. So to make x a subject, we need to multiply x across and divide cos 42. So we're going to have x equals 1.64 over cos 42. And that's it, guys. Once you smash this in your calculator, you should get a final result of 2.21 meters. And that's it, guys. Hope this helps and you get the answer. All right, number 13. So Sandeep recorded the length of time in minutes that each of 100 adults went for a walk one Saturday afternoon. All right, cool. The cumulative frequency table gives information about these times. Okay, guys, one key note here. The cumulative frequency just means that you're adding up the frequencies as you go along. In this case, there is no frequency, so this is already done for you, unlike other questions. Now, part A. On the grid, draw a cumulative frequency graph for the information table. Alright, this is easy. So all you gotta do is highlight two things, yeah? Highlight the end points of 40, 50, 60, and also highlight the cumulative frequency. So these are like your coordinates. And all you gotta do here is match the time with cumulative frequency. So for the first case, we can say up to 40 minutes, which is here, there was a cumulative frequency of 6. Now looking at this carefully, like, so this is 20, so that means half of it is 10, so the midpoint is 10. That means every single block, and there's 5 blocks, must be going up in 2s. So it'll be 2, 4, 6. And you're going to keep on doing this, yeah? 50 is going to be 20, which is here. 60 will be 56, so 50, 2, 4, 6. This is so much better. 70 all the way up to 84. Yeah, not bad, isn't it? So this kind of questions you can always, hopefully we get it right, inshallah. 90, this would be 95. Is that right? And last one, 9, which is always at the end, always should be the top, 100. And by the way, guys, it should always start from 0 as well. So this is also important. And then you just draw like a little nice snake tail, yeah? Remember, you're not using a ruler, you're always going to curve. Try and make it as accurate as possible. So something like, something like that. Don't try and make it too edgy, yeah? Something cool. So that's done. Now part B. So use your graph to find an estimate for the median length that these adults went for a walk. By the way, guys, yeah, when I'm graphing on the screen, the actual answer may vary by 1 or 2 points here. So don't take this as absolutely perfectly right. This is kind of a close, rough estimate, yeah? My answer might be slightly different from the mark scheme. So the median in this case literally means, okay, we're going to find the middle adult. So in this case, so what that really means that since you got 100 adults, the median will be the middle person, so the 50th adult. If it's the first quartile, the 25th. If it's the third quartile, the 75th. So in this case, the 50th is here. And all you got to do is draw a straight line across. Okay, make it hit the median, which is somewhere around here. So I don't know exactly where that is. And then just shoot down. Now I'm going to just pick this line over here. So this could be the answer. So the minutes here would be, let's see, 50, 55, 6, 7, 8. So it could be around the 58th minute, I think. Yeah. So we say that the median length of these adults, the ones who went for a walk, would be 58 minutes. And that's it. Now lastly, let's check it out. Let me scroll down a bit. So one of the 100 adults is chosen at random. Cool. Use your graph to find an estimate for the probability that this adult went for a walk for more than 72 minutes. Alright, so this is not bad. All you do is look at the 72nd minute, shoot up the graph, so it should be like here. And then we just shift it to the left, somewhere here and there. And we just ask ourselves, alright, to find the number of adults that was more than 72, so this is basically like the end of the tail here onwards, we can just say, alright, up until, I don't know, let's see, what's that, 80, 2, 4, 6. So we can say that the first 88 adults were less than 72 minutes. That means the remaining 12, the distance between 188, 12, went for more than 72 minutes. So these are kind of like my dad and uncle. They love doing a lot of walks. So this would be 12 people. So, oh yeah, and because it's a probability, it'd be 12 out of how many walkers again? 100. 12 out of 100 adults. And that's it. You can leave it this answer, a decimal, fraction, all good. But that's it, guys. This is the end of question 13. All right, and finally, number 14. So here we need to simplify fully this entire expression. Okay, so this is just straightforward. All you got to do is always attach the power outside the bracket to every single term. So in this case, we're going to have x to the power 12 multiplied by 3/4 times y to the power of 8 multiplied by 3/4. And yeah, you can just put this in a calculator. When you do this, you got 12 times 3/4. So 12 times 3 is 36. 36 divided by 4 is 9. Same thing. 8 times 3 is 24. 24 divided by 4 is 6. Yeah, and that's it. That's A done. For part B, it says that given that 3 to the power n equals 3 to the power x over 9 to the power y, find an expression for n in terms of x and y. Okay, does look kind of weird, but there's a super easy way to think about this, yeah? When you're working with indices, yeah, it's always best to make sure they have the same base value. So we got 3 and 3, so it looks good, but then we got 9. And we can kind of realize that 9 is actually kind of the same in indices as something else. 9 is the same as 3 squared. So rewriting this, we've got 3 to the power n equals 3 to the power x over 3 to the power 2y. Okay, so just replace 9 with 3 to the power 2. And now using the rules of indices to kind of level them, we can kind of say, all right, that on the right hand side, if we're dividing terms, this means we're subtracting the power. So it'd be x take away 2y. So 3 to the power of x take away 2y. And yeah, almost done here. And now this equation is kind of telling us that the left hand side must equal the right hand side. In that case, this means that n must equal x minus 2y for this equation to be true. And that's it. And that's what they want. They want an expression for n. We got it in terms of x and y. And we got it. So we got A, B, C, and D are points in a circle at center O. A of C is a diameter of circle, which means this straight line across with 2 radiuses and a perfect diameter. Angle AOD is 98 and it's labeled here. Work out the size of angle DBC. So D going to B going to C. In other words, the angle between it. We can call it X. Okay. So give a reason for each stage of your working. Alright, so they want us to be descriptive as well. Now, when you look at this one, we need to observe 2 things, yeah? First thing is this kind of spacecraft shape, which is a very common shape, which looks like that. This means here that whatever angle you get here, the angle in the center is always 2 times the value of the angle at circumference, yeah? So for instance, since this is 98, this needs to be half its value. So this would be half of 98, meaning 49 degrees. So that's easy, yeah? Now another shape you need to realize is the fact that we have a diameter. And this is kind of the shape of a semicircle now. If you think about it, this is just a semicircle. And one property that's important to know, that any triangle inside the semicircle is always right angled. So this means this is always a right angle. In other words, 49 plus x must equal 90 degrees. And if you subtract these two, well, you get your answer. So 90 take away 49 should give us 41 degrees. And that's it. And just to be clear, the properties I was talking about earlier are these. And they are these two. Well, the first one being the angle at the center of a circle is twice angle to circumference. This means, like we had earlier, this was 98 degrees, so therefore this must be 49. And the second type was the fact that the angle in the semicircle is 90 degrees. So you got a diameter cutting across, meaning any single triangle you form, could be there or downwards, like here for instance, will always be 90 degrees. So anywhere you do, like from one point to the other point, yeah, like this, and so on, yeah. And that's it. That's literally it. All right, number 16. So the following table gives values of x and y where y is inversely proportional to the square of x. All right, before we carry on to the rest, inversely proportional means something like this, that y is proportional to the inverse of the square x. So a square of x is x squared. The inverse of it means it's reciprocal, so 1 over. Symbol over here that we got, this kind of little fish thing which looks like an alpha. This is some proportionality symbol, but it can be converted to an equal sign, which is the same as equals some scale factor. So what they really want us is to make an equation that looks like this: y equals some scale factor k over x squared, where k is something we have to solve. That's literally what we need to always find, the value of k, the scale factor. Now let's look at the question. A, find the formula for y in terms of x. So in other words, we need to figure out what k is, and then we have an equation for y in terms of x. Now with this table over here, we just plug in, I don't know, 2 different values, or one of them, find the value k, and you're done. So I'm just going to use these two, because it looks quite simple to use. So this means when x is 3, y is 4. So this equation means 4 equals k over 3 squared. 3 squared is 9. So solving for k by multiplying 9 across, 4 times 9 is 36. So 36 equals k. So therefore, our formula for y in terms of k is y equals 36 over x squared. And that's it, guys. That's this one done. Now for the next bit, it says that given that x is positive, i.e. x is greater than 0, find the value of x when y is 144. Alright, so using the formula above we just got, let's go ahead and plug in, replace y 144, yeah? That's going to equal 36 over x squared. Now, let's go make x squared a subject, so timesing x squared across and dividing 144, we're going to have x squared equals 36 over 144. Now, all you want to do is find x, so square root in this. You're going to have x equals the square of these numbers, which is square root of 36 is 6 over 12. And because it says x is, what's it called? X is greater than 0, we don't need to write plus minus. Only because they want a positive result, so they only want the plus answer. And then, yes, 6 over 12 is just half. I mean, you could just put this in your calculator and square root, and you should get half as well. But either way, guys, this is the end of the question. Okay, guys, I'm not gonna lie. This question was a bit challenging, and it's quite different to what you've seen before. But anyways, let's try and break it down to make it as simple as possible, yeah? So, question 17. The table gives information about the first 6 terms of a sequence of numbers, all right? So here are our first 6 terms from 1 to 6. Now for the term of sequence, we got 1 times 2 over 2, 2 times 3 over 2, 3 times 4 over 2, and so on. So what's actually happening is that they're borrowing the term number here and substituting here, and then increasing the next value by 1 to make it 2. Same here, they got number 2 to correspond here, and they increase by 1 to get 3. They put 3 here, increase by 1, and so on. And it's always dividing by 2. So dividing by 2 is fixed. Alright, now it tells us that we need to prove algebraically that the sum of any 2 consecutive numbers, so consecutive terms, so basically one after the other, of the sequence is always a square number. Alright, So we're going to get to that square number in a second. We just need to pick two consecutive terms and kind of write it algebraically. So let's find the mth term, yeah? Suppose the mth term at this stage, if the term number was n, we would copy it here, so it would be n. So let's make a little table. We've got n and n plus 1. These are two consecutive terms, yeah? So I'm going to use a table. So this means we're going to have n times increased by 1, n plus 1 over 2. So the next term would be n plus 1, increase it by 1, times it by n plus 2 over 2. Now it's telling us the sum of these two consecutive terms. So this means n over n plus 1 over 2 plus n plus 1 n plus 2 over 2 must equal square number. So this is what we have to prove, yeah? So let's go ahead and try and simplify this this fraction. So summing this up, because they have common denominators, we can add the top directly. So let's expand this then, make it all over 2. So you've got n times n, so you've got n squared plus n times 1 is n, plus, now expanding the double bracket, you got n times n is n squared, n times 2 is 2n, and 1 times n is 1n, 2n plus 1n is 3n, and 1 times 2 is 2. And we know it all has a common denominator of 2. Now tidying up the top half here, so let's just go ahead and tidy up top half, guys. Collect like terms. So you've got n squared plus n squared is 2n squared, plus n plus 3n is 4n's, plus, and you just got a constant 2. And all of that over 2. Now looks like we're getting somewhere, yeah? Now let's go ahead and see if we can simplify this. Yep, they're all in 2 times table. Divided by 2, you get n squared plus 2n plus 1. Alright, so we're not done yet, yeah? Because the thing is, it tells us that this sequence is always a square number. A square number means we need something squared. In other words, they want us to try and factorize this last step. Now this can really catch you out, yeah? So to factorize this quadratic, we can just put in a double bracket like that, yeah? Just start something simple. We know that the first terms on both sides is n, because n times n is n squared. And we need two numbers that multiply to make 1. Well, the only possibilities is 1 times 1. And the same two numbers that sum to make 2. Well, 1 plus 1 is 2. So that means they both must be 1 here. Plus 1 and plus 1. And guess what, guys? And then you combine together, this is literally n plus 1 squared. And that's it, guys. We're all done. Alright, number 18. So the functions f and g are defined as follows, yeah? So the first function fx is kind of like a fraction, and gx is just some sort of linear term. Now, part A. State which values of x must be excluded from any domain of the function f. Okay, so we're talking about the first function fx, yeah? Now, when it says state the domain that must be, like state the value x that must be excluded from a domain, all it's asking here is that we want to check which values of x is not allowed. So when we got fractions involved, we need to ask ourselves, okay, what doesn't work? So one important thing about fractions we need to know is that we can never divide by 0. Okay, in other words, the denominator cannot equal 0. So the first thing we want to is try and figure out what values of x will make it 0. That's what we need to exclude. So then we can say, all right, let 4x minus 3 equal 0, because we can't have that. Solving for x, you're going to have, therefore, plus in 3, so 4x equals 3. And dividing by 4 across, x equals 3/4. So this is the value of x that we must exclude from our domain. Otherwise, you're going to get something over 0 and then it's undefined. Okay? Now, part B. Find fgx. Simplify answer. Alright, this is just a standard one, yeah? This means you're going to have to put g, the function of g, inside f, yeah? In other words, you're going to put this into here. You're going to replace x, the x is here, with x minus 5. So let's do it, yeah? So if we got fgx, I'm going to use different colored pens, yeah? I'm going to replace this x and this x with x minus 5. So now we've got x minus 5 over 4 times, and then replace that with blue, x minus 5, and then the original minus 3. Now we just simplify that. So x minus 5 just stays at the top. The bottom, you can just expand the bracket. So 4 times x is 4x. 4 times 5 is minus 20, and then minus 3. And then just tidy this up a bit. You're going to have x minus 5 over, and then the bottom would just be minus 20 take away 3, which is 4x minus 23. That's it, guys. Like, nothing more to it. Now finally, the last part, C. Express the inverse function this thing, so f minus 1 in the form of, well, the same. I can never really read this, man. It's always kind of weird to read. Now, to find the inverse function of f, so let me just clean this up a bit. All you got to do is just do the same steps as always, yeah? So just say, all right, so basically replace all your x's and y's. So let fy equal y over 4y minus 3. And this time, we just equal it to x. It's always like that, yeah? Replace all letters of y, make it equal to x, and then just rearrange it to make y the subject. And you're done. That's always the same thing, yeah? So we're basically trying to find all of these lot, yeah? And make y the subject. Now, to do that, to make y the subject easily, you always want to clear the fraction, yeah? So let's times 4y minus 3 across. So we're going to have y equals x times 4y minus 3, which is 4xy minus 3x. Remember, we just times this across here. Now, all you want to do is isolate the y. So basically, move all the y's to the same side, yeah? So I'm going to move 4xy to the left side. So we've got y and 4xy. To do it, we subtract it. So we've got y minus 4xy equals, and you're left with minus 3x on the right. Now, next step you want to do is factorize the y out. So we're going to have y bracket 1 minus 4x equals minus 3x. And lastly, guys, all you got to do now is simply divide this bracket to the other side to make y the subject. So you can get y equals minus 3x all over 1 minus 4x. And you're done. And then you just change the y into to that symbol they want. F to the power of minus 1x. So this is the inverse symbol, equals minus 3x over 1 minus 4x. You might have an alternative answer, by the way, yeah? Other alternative answers, which is fine, would be 3x over 4x minus 1. Because if you just flip both of these, it's the same result. So you can have this result or this result. Either one is fine, guys, yeah? Okay, and the last bit. So part of the curve of equation y equals hx is shown on the grid. Okay, so you got this hx curve. Find an estimate for the gradient of the curve at the point where x equals minus 0.5. So minus 0.5 is here, yeah? So it's talking about finding a gradient at that point. In other words, you just got to draw some sort of tangent line, like this, yeah? Show you're working clearly. All right, so you kind of just need a ruler. So all you need to draw is maybe, I don't know, something like that, yeah? Some sort of straight line. Probably better, I should have used like a ruler or something. And all you want to do is just pick two random coordinates. I don't know, maybe, it's kind of hard. So probably something like here and something like here or something, yeah? So this point here and this point here, let's have a look. This is just 0, 18 maybe. And this point here is just, where is it? So it's minus 1, 11, yeah? And now all you want to do is just kind of find a gradient of this line. So the gradient formula is always the change in y over the change in x coordinates, yeah? So well, the change in y is just the difference between the y, so 18 take away 11. And the same thing, change in x would be 0 take away minus 1, so 0 take away minus 1. And when you put this in the calculator, well, you should get a gradient of 7 or around 7. Because I'm not using a ruler, I might be a bit off, guys, yeah, so double check. But I think I've checked the math scheme and the answer should be kind of, yeah, the answer is actually 7. It's all good. Anyway, guys, see you in the next one. All right, number 19. So the diagram shows a sector OAPB of a circle center O. All right, so this is just a nice simple sector, yeah, part of a circle. Now AB is a chord of the circle. AB, so AB, yep, it's just a chord. Angle AOB is 80 degrees. The area of the sector of the whole thing is 25 over 2 pi. So this is actually very important, yeah. And just quick note, yeah, this little area here is called a segment. This area here is called, well, it's a triangle. I think we know that one, yeah. Now work out the perimeter of the shaded segment. Give your answer correct to 3 simple figures. Okay, so it looks to me that all you really need to work out is this arc length here, as well as the, and since it's part of a circle, these two will be the radius r, yeah. Okay, not too bad. So let's just recall some formulas, yeah. We need to know firstly that the, what's it? The circumference of a circle is 2 pi r, yeah. This is a fraction of a circumference of a circle, yeah. So let's say this is 80 out of 360 degrees. So the length arc, which is what we need, is a fraction. So 80 over 360 of your circumference of a circle, 2 pi r. That's really how you calculate, yeah? We also know that the area of a circle, there's a bunch of formulas, guys, yeah, is pi r squared. And the area of a sector, so this area of a circle, the area of a sector is a fraction of the area of a circle. Again, it's like 80 out of 360 degrees. So 80 over 360 times your area of a circle. Okay. Now, what do we need to calculate, yeah? So we have to always think about the objective, yeah? So since we want the perimeter, we can only work out the perimeter if we know what the radius is, yeah? So we can actually answer this question if we can work out the radius. Since they gave us the area of a sector, we already know this value here. It's actually 25 over 2 pi. So updating that, put in 25 over 2 pi, we can just solve it. So to find r, all you do is literally just smash everything to one side, yeah? And before doing that, looking on both sides, we can cancel pi because they both have pi. So dividing pi on both sides, left of that. And now we can divide 80 over 360 across and then square root to find r. So you can have 25 divided by 2 all over 80 divided by 360 equals r squared. So putting all of this in the calculator and then square rooting your answer, you should get a radius of 7.5. That's what you should have, yeah? Now, because you got the radius here, we can update these values right here. So again, we're trying to find the perimeter, yeah? So just let me see, what we're trying to find, what perimeter exactly? Work out the perimeter of the shaded segment. Okay, so they're talking about this arc plus this bit here. Okay, so you want to work out this length too. Man, that's a lot of steps. Okay, cool. So let's have a look. What should we work out? Let's work out the length of this arc, yeah? This arc is L. That's what we called over here. Since we know what the radius is, we could just plug it back in and we got it. So the length of the arc L. Okay, so we should get roughly 10.47 ... Okay, so that's done. So we found this bit. Arc is covered. All right, now we just want to work out this triangle, the length of this opposite length from 80 degrees, yeah? Let's just call it X. Now, looking at this carefully, this triangle, the only way we can solve it is using either the sine or cosine rule, right? But because we've got three lengths, X, 7.5, 7.5, and an angle, we can only use the cosine rule. So let's just recall the cosine rule, yeah? The cosine rule formula said that we have a squared, which is equal to b squared plus c squared, and we must minus 2bc cos a. And by the way, this is given in the in the front of the booklet, yeah? So replacing all the known values, because we got one angle, this is ultimately an a, yeah? That means that the length opposite the angle must be little a. And that means these two values are b and c. So updating everything, we got x squared equals 7.5 squared plus 7.5 squared again minus 2 lots of 7.5 times 7.5 cos 80 degrees. Okay, perfect. So putting that all in, so putting all of this in your calculator and then once again square rooting your answer, so square root whatever your answer says, you should get a value of, I think, 9.64 ... And then guys, we're pretty much done. Because we got the length of the arc and we got our x value, which is here, so we basically got everything. We got the arc plus this value, so that's just two lengths. We just add them up to get the perimeter. So the final answer would be 10.47 plus 9.64. And doing so, you should get an actual perimeter length of 20.1 centimeters. Yeah, and that's it, guys. That's it. We're done. All right, number 20. So we got an equation x equals 6a over b minus a, and it tells us that each of these letters have been rounded to a certain number of significant places or decimal place. So when they say that, it means that it must have been something else before, something bigger than 3 sig figs or something bigger than 1 decimal place. Now, it wants us to work out the upper bound for the value of x. So in other words, maximize this. Give your answer as a decimal correct to 3 significant figures. All right, nice little trick for these questions. So what I usually do to know how to maximize this value to get an upper bound for x, we need to firstly maximize the top half and minimize the bottom half. Why? Is because the greater the top and the lower the bottom, the greater the end result. Now, how do we maximize 6a? Well, we need to find an upper bound for 6a. So we need to find upper bound for a. So let's just do our bounds for a and b first before anything else. So always set up like that, yeah? where a and b is always less than or equal on the left and greater and less than to the right. So on a, we know it's 3.46. I always write 3.46 here and 6.3 here. And then I just added 5 to both of them. So 5 and 5. So this tells us that for a to be true, to be rounded down to 3.46, it has to be just less than 3.465, whatever, to 366. So that means on the left hand side, it will be 3.455. The trick is always to reduce this figure by 1. And same thing here. If it's 6.35 here, reduce this figure by 1 to get 6.25. Because rounding this up to one decimal place, this 5 is obviously 5 or bigger, so this will round this 2 to a 3. And because it's equal to it, it's possible. But yeah, that's all you need to know. Now, looking at what we need, we just need to maximize a, so we need to pick this value here. And we need to minimize the bottom, b minus a. So to minimize b minus a, we need to have the smallest difference. And the smallest difference is possible if we pick the smaller value of b minus the bigger value of a, because that has the smallest gap. These two are closest to each other. You can't pick any other combination because the gap ain't as small. So therefore we can say the upper bound of x equals 6 times the upper bound of a over, or what is it, the lower bound of b minus the upper bound of a. Okay, so just replace these values. So we want this value for a and this value for b. Plug this in the calculator and you should get an answer of 7.46. 3 significant figures. And that's it, guys. So the diagram shows two similar bottles, A and B. Alright. Bottle A has surface area of 240 and bottle B has a surface area of 540 and a volume of 2025 centimeter cubed. Now here they want us to work out the volume of A. Alright, cool. So this is just a question about proportionality, yeah, because they tell us they got similar bottles. So it's kind of like similar triangles, yeah. Now all you need to know is just two nice formulas, yeah. We need to know that the ratio or the proportion of B to A, so let's say the surface area of B to the surface area of A must equal some kind of scale factor, yeah, some scale factor squared. Because you're dealing with areas, it will be squared. And we also need to know that the volume of B to the volume of ball A must be the same scale factor but cubed. And if you had length, it will be the same thing but just scale factor power 1. Okay. Now all they want us to do is basically plug in everything and see how to get A, yeah? So let's do let's use the first equation here. Let's plug everything into this equation here because we got most of the values. So we know what B and the surface area B in A is 540 over 240, and it must equal a scale factor squared. So plugging this into your calculator and then square rooting to get scale factor, you should get a scale factor of 3 over 2. And that's it. Or you can say 1.5, yeah, to be more exact. Now, to work out the volume of A, we use the same formula, so plug everything back in. Since we got the volume of B, we can say, all right, the volume of B is 2025 over the volume of A is what we want, must equal that scale factor 1.5 to the power of 3. And all you do is just make VA the subject. And to do it, you multiply VA across and divide 1.5 cubed across. So you're going to have something like 2025 over 1.5 cubed equals VA. And then when you put this in the calculator, you should just get a straight up answer of 600 centimeters cubed. And that's it, guys. Question done. All right, number 22. So it says write 5 plus 12x minus 2x squared in the form of this, where a, b, and c are integers. Okay, this particular form is one of something known as completing the square, yeah? So completing the square. Now, to move something into that particular form, and by the way, this is not a usual form, we should always rewrite this in terms of the standard quadratic formula, yeah? So let's go put this in order, yeah? So we got minus 2x squared plus 12x plus 5. Okay, so now we're going to try and attempt to complete the square and return it to that form, yeah? So what I would firstly do is always get rid of the coefficient in front of x squared, yeah? So we want to factorize minus 2. So let's just take minus 2 out for a second, yeah? And make one big bracket. So by factorizing minus 2 out, we're going to divide every single term by minus 2. So this means that the first term here is now just x squared, just like we want. Dividing 12 by minus 2, you get minus 6x. Dividing plus 5 by minus 2, Well, you can just write minus 5 over 2. Okay. Now let's ignore the minus 2 for a second, yeah? And we're going to attempt to complete the square on this bit, yeah? So to complete the square, all you got to do is just look at the first two terms, copy out the same term without the square, so you're going to have x minus, then you half the 6 and get 3, wrap it in the square, copy out the third term, and then subtract it by minus 3 squared. So subtract minus 3 squared. And of course, copy everything back as well. So, oops, copy the big bracket, minus 2, big bracket. And now we just want to just times everything by minus 2. And by the way, we're not going to expand x minus 3 squared, because looking at the general form, they want as x plus c all squared. So something needs to be in a bracket, and this is pretty much the right bit. So let's go ahead and times everything by minus 2, yeah? So we've got minus 2 times x minus 3 squared. That's just minus 2 times x minus 3 squared. Just stick it on. And then times minus 2 against all of these lot, yeah? So what I'll do, put all of these terms in your calculator. Then that times it by minus 2. You should get plus 23. And that's it, guys. We're actually one more step away. So now looking back at the general form, they want it to be a constant verse. So that means 23 should be in front. So just putting it up here. Should be 23 and then minus 2 times x minus 3 squared. And yep, that's it. This is the end of the question, guys. We've actually completed the square. Alright guys, number 23. So the diagram shows a solid pyramid ABCDE with a horizontal base. So that's the ground. The base BCDE of the pyramid is the square of side 10. Alright, so that's quite useful. The vertex A of the pyramid is vertically above the center O. So it's vertically above, meaning this is perpendicular to the ground, yeah? Okay, such that AB equals AC and so on. So every length is the same. So every single diagonal length is the same too. Now, the total surface area of the pyramid is 360 centimeters squared. So that's the area of all the faces. Work out the sides of the angle between AC and the base BCDE. Give your answer correct to 3 different figures. So AC and the base. So we're trying to find, basically, to make it easy, if we just draw a diagonal line cutting to the base, we want to find this angle here. And that's how we do it, yeah? So let's call this X. Now, to get that, we need a few things, yeah? We need to firstly know this little diagonal length is, which is perpendicular to this length here. So this is actually a right angle triangle. So let me just plot it here. So we got O, C, and A. We don't actually know any lengths. All we want to find X here, but we got a vertical height H, but we don't know its diagonal length. But one way to get diagonal length is to realize that O is in the center. The reason why we know it's in the center, because it tells us obviously. But what we could do is draw, let's say, a diagonal line across here, yeah? This would be the midpoint. Well, a bit more to the center like here, I guess, yeah? This would be the midpoint. And this is, of course, also right angled. And we know that this has a length of 5. And this one also has a length of 5. So we can actually work out this length here using Pythagoras Theorem. And then once we got this length, we can also work out this height. And having that height, well, you're pretty much done. So what we could say, we can have firstly work out this small triangle here. We got a triangle of length 5, 5, and call this length y. Using Pythagoras Theorem, it would be 5 squared plus 5 squared equals y squared. So this is 25, so this is 50. So therefore, y equals the square root of 50 if you solved it. Okay? And this would go over here, the length of OC, because that's the OC we just found. Alright, so the next crucial piece of information here is the fact that we can call any of these long diagonal sides from the top of the pyramid to the bottom, to the base, D's, yeah? So let's call all these D. So I'm going to call this long one D, so this must be a D. Okay? Next, to work out the value of D, we can start using the final piece of information, which is that the fact that the total surface area is 360. So what is this total surface area? Well, we know that it consists of a square on its base, which has an area of 100 because 10 times 10 is 100. Plus we got 4 triangles. And we know that it has a base of 10, but we don't know its height. In fact, we know that the height is actually, well, it's not D, that's the diagonal height. Let's call this height, I don't know, already used the letter H, haven't we? Let's call it L, why not? Let's use the letter L. So the height is L and the width is 10. So therefore, plug in everything we know. Surface area is 360 must equal the area of a square, which is 100, plus 4 times the area of a triangle, which is half, times the base times the height, which is L. And now just try and tidy this all up. So subtracting 100 across, you get 260. Tidying up this part here, so you got 4 times a half, which is 2, times 10, which is 20, so 20L. And then finding L, just divide 20 across. You're going to get L equals, well, 260 over 20 is 13. Okay, not bad. So that's an important figure right here, yeah? So remember, that is the vertical height, yeah? So just updating everything here. So let's redraw this triangle, yeah? It's ACD. So you got ACD. So guys, with these problems, it's always good to take your time, yeah? So ACD, width is 10, vertical height is 13. We know also the fact that the half length up to here is 5. And one thing we can notice, the only way to obtain this diagonal D, the one we label D, is to use Pythagoras Theorem and just take this small triangle out. So guys, there's a lot of Pythagoras involved here, isn't it? So you got 5, you got 13, and you're trying to work out D. So using Pythagoras, we can say, all right, wait. Yep, so using Pythagoras, we're going to have 5 squared plus, 5 squared plus 13 squared equals D squared. Basically, I paused for a second because I was thinking this must be a 5, 12, 13 triangle, but it can't be. Because if this was 12, then this would have been 13. Yeah, just some Pythagoras rules I remember. So therefore, dealing with this, so 5 squared plus 13 squared, just adding them up and then square root your answer, you're going to get something like 194. So then the square root of 194 is just root 194. By the way, guys, just leave your answers in surds, yeah? Don't bother like putting them into decimals, or you could really screw your final answer. Now let's see. Let's just update everything here. So we're trying to find what exactly? Trying to work out the size of angle AC, yeah? This angle X. We've got this triangle that we pulled out earlier. We found D, so this D is now root 194. All right, perfect. We're on the last step. So using this triangle, we can use Sohcahtoa now. Finally, something decent. Sohcahtoa. All right. So to use Sohcahtoa, we just pick 2 things that's involved in terms of length. Well, if the angle is X, this must be opposite, but we don't need that. We need the hypotenuse and the adjacent. So H and A. And the only thing that's H and A or A and H is cat. So if we're using cat tells us what? So let's have a look. Cat tells us that we're going to have cos of the angle. So cos of the angle X, let me scroll up a bit, equals adjacent over hypotenuse. So adjacent, which is root 50 over hypotenuse, which is root 194. Whew, can't believe we reached this far, guys, yeah? And taking the cos inverse of this, you're going to get an angle of 59.5 degrees. And that's it, guys. This question is done. And here we are, guys, number 24. So what do we have? A box contains marbles. All right, 4 of them are red and the rest of the marbles are yellow. Okay, so let's define some things here. So you got 4 is red and the rest is yellow. Let's call them n. So okay, so this means the total number of marbles must be 4 plus n. Okay, red plus yellow. Now Antonia takes at random a marble from the box and does not replace it. Okay, so when she takes it, she keeps it. Okay, so it decreases. Sergio then takes at random a marble from the box. The property that Antonia and Sergio both take a yellow marble is 0.7. Okay, so this is a property that one takes yellow and the other also takes yellow, and it must be 0.7. Work out how many marbles were originally in the box. Alright, so not too bad. So to do these kind of questions, all you need to do is figure out what is probability picking a yellow algebraically, yeah, and then yellow again. Well, to get a property of yellow and then yellow again, first things first, we have how many yellows? We have n yellows. So we have n out of a total of 4 plus n yellows, okay? And now the second yellow, so always multiply when we go across, we now have 1 less yellow. So we have n minus 1 yellows, yeah? Because imagine you had 10 yellows. And if you take 1 out, you're going to have 9 yellows, or 10 minus 1 yellows. And the same thing applies. This means the total is now 4 plus n minus 1, because you took 1 yellow. And that's it. So all you got to do now is deal with this. And by the way, guys, 4 to 1 is 3. Yeah? So you can rewrite it as 3 plus n. Okay, And all of this is supposed to apparently equal 0.7. And yeah, now all we do is literally just deal with this equation and you're done. Find the value n and you found it. So multiplying these fractions across, when you multiply fractions, you times horizontally. So it'd be n times n minus 1. We're going to have n squared minus n over, and then 4 plus n times 3 plus n. Well, that's just a double bracket, yeah? That's 4 plus n times 3 plus n. All of that equals 0.7. Now dealing with the bottom half here, so let's deal with the bottom half for a second. So expanding the bracket, you're going to have 4 times 3, which is 12, plus 4 times n is 4n, n times 3 is 3n, so that gives you a total of 7n, plus n times n is n squared. Alright, so that's just the bottom half here. Now what we're going to do, we're going to multiply this across here, so clear the fraction. So times in the denominator across to 0.7, we're going to have a total equation of, on the left side, of n squared minus n equals 0.7 times these lot, yeah? Okay, so 0.7 times 12 is 8.4 plus 0.7 times 7n, that's going to give us 4.9n plus 0.7n squared. Alright, almost done. All we're going to do now is rewrite this as a quadratic, yeah? So we're going to multiply, we're going to move everything to one side. So let's move these two to the right, yeah? So subtracting n squared and adding n, we're going to have now, plus I'm going to write this in terms of the right order, yeah? So 0.7 take away 1 is going to give us minus 0.3n squared plus 5.9n plus 8.4, and that should all equal 0. So all I did is just move this to the right, yeah? And I just put the equal on that side as well. And now to solve this, just use the quadratic formula, yeah? So according to the quadratic formula, and I'm just going to do it on this side, yeah? Actually, let me see if I can move the screen a bit. Nah, oh yeah, I can. So quadratic formula tells us that we have minus b plus minus the square root of b squared minus 4ac, yeah? All over 2 times a, where each of these letters, a is minus 0.3, b is 5.9, and what's it, c is 8.4. And plugging in these values, you're going to have an n value of minus 4 over 3, or n equals 21. And now since, you know, we're dealing with how many marbles, and we know n must be a whole number, one of the answers cannot be a fraction, yeah? So this is wrong. N is negative, so it doesn't make sense. So that means that the total number of marbles, yeah? So remember, they want a total number, will be this. So it'll be 4 plus n. Since n is 21, it'll be 4 plus 21. And that gives us a total count of 25 marbles. And that's it, guys. Hope this video helped. And if you enjoyed it, you know, give me a comment, let me know. But otherwise, I shall see you guys next time. Ciao.